My name is Suji Maniam. I am a founder and CTO at Elephant Scale. I run a lot of training classes in big data technologies, including Kafka, machine learning, and DevOps. So that's my background. And I'll share my emails with you guys in a second. And so when I teach Kafka, we teach Kafka using a single node system. And a lot of the time I get a request to say, how can I run Kafka in a distributed fashion, right? Because that's how Kafka is written. And this whole project started as a solution for that, and then kind of took a life of its own, right? So I'll kind of walk you guys through the steps I went through. Okay, so let me end the poll here. Okay, thank you for taking the poll, guys. Very good. So let's talk a little bit about how we develop software, right? And I've done, I'm a software developer by trade. I develop a lot of software. Could be web applications, backend applications. So let's say I want to develop a web application. What happens? First thing you do is you have to set up your machine, right? And this is from, my web apps tend to be a lot of PHP-based apps and Python-based apps. So what you have to do is, first you have to set up a web application environment. You have to install PHP or Python, and then install like a little web server. Could be Apache or Nginx, and then you set up your database, right? And then let's say, your web application, you're uploading images, right? So you need to basically set up like some sort of image library, like ImageMagick, to process the images. You are doing like password management, right? Then you have like a crypto library. So you're installing all of this on your laptop, right? And this is fine. I mean, right? This is why, we actually, developers, we get powerful laptops because we want to be able to do our development on our machines. But as you can imagine, this can get pretty out of hand, right? And here's another similar experience in, say, Java development, right? So let's say you're doing some Spring Boot application. So, you have some version of Java, right? Could be Java 8 or Java 11. Then, again, database, right? Maven build tools, and maybe Redis as your caching server. So pretty soon, right, you're going to start developing, installing pretty much everything on your laptop. And here's a big data stack, I have on my laptop, right? So Java, Cassandra, Spark, Kafka, all of this. Remember, we are installing all of this natively, right, on our laptop. So we kind of keep at this for a while. Your laptop will have so much stuff, right? Because as you go from project to project, let's say you worked on Java project, so you have a bunch of Java stuff. Then you're working on some Python project, then you have a bunch of Python stuff. So pretty soon, your laptop is just a maze of libraries and things you installed, and almost very hard to manage. There are some best practices you can follow, right? You can sort of, you can create virtual environments and things like this. But again, your machine is still, right, installing everything natively. And so is there a better option, right? Basically, because after a while, how do you, especially when you're switching from, and I went through this recently. I was working on a Python project that wanted a library or a certain version. And at the same time, I had the Java project that had another version it wanted. And they were kind of both conflicting, right? So how do you manage this? It becomes a little messy, right? So the idea here is we want isolated and clean development environments. And this is the idea for virtual machines, right? So everyone kind of went through this, and people said, no, we need a better solution. So one solution was virtual machines. So if you use like VMware, VirtualBox, that's what they did, right? They actually give you like an isolated machine you can use, and then right, everything you do is specifically contained. But the trouble with these machines they were very resource intensive, right? So typically on your laptop, maybe you can run one, but maybe not two. Maybe not, right? Because these are very, very intensive applications. So they will really consume a lot of CPU and memory. So yeah, you can run like one at a time, but still it's not the answer, right? Because they are kind of, very resource hogs and not a very high performance. And then Docker came along. So Docker, what Docker did was it kind of gave us the same level of isolation that we get these virtual machines, but with much less baggage. What do I mean by that is it's very lightweight. Why is it lightweight? Because if you think about Docker, right? Here's a comparison between virtual machines and Docker, just to kind of give you a little background, right? So on my left, I have a virtual machine. So what they do is They run on top of a virtualized layer, and then each VM you can see has an entire operating system inside it. So let's say this is Linux, right? So you install Linux on a VM, and then you install your application stack. So let's say you want, say Windows, right? You'll install Windows here, and then right. So each VM actually has the entire full operating system inside it. So as you can imagine, it's like it's pretty hefty. The way Docker did this is pretty innovative. So what they did was like they said, look, we are not going to have a separate operating system. We are going to share the operating system of your, say, laptop, right? So all the Docker applications, containers you can see, right? They share the same OS. There's no operating system built into Docker, right? But what they do is they give you an isolated environment for your application and the libraries. That's pretty cool, right? Because this is exactly what we wanted, right? We want an application level isolation. We don't really need OS level isolation, right? That's what the VMs are giving us, right? In VMs, in a VM, so let's say your Mac laptop. On top of the Mac laptop, you can run your Windows, Windows VM, Linux VM, right? Because right, each VM is completely isolated. But on Docker, you don't have the same OS. So you're running on Linux, these are going to be Linux as well, right? And then it's done by the Docker engine. So the separation is done by Docker engine. So as you can imagine, this is a much more lightweight solution. So typically when you start up a VM, it'll take 1 or 2 minutes to boot up. Docker, as you will see when I do the demos, will start up in seconds, right? So, and also you could run easily 10, 20 Docker containers on your laptop very easily, no sweat. On VMs, maybe you can run 1, maybe 2, right? That's stretching it, right? So now that we have a very lightweight isolation level, it's much easier to develop applications, right? So, and that's kind of the way I'm also doing this. I'm actually, so last project I did, we basically, containerized everything. Meaning, so for example, let me jump ahead a little bit and show you guys, right? So now what I do is I am actually when I run my application, see, I'm not running my natively. I'm running a Docker container. So it's a little box, like a container box, that is running my Java application. Then I'm running another container, right? That's running a Python app. And as you can imagine, they both have different libraries and different, different dependencies installed and completely isolated. Also, when I'm running MySQL, I'm not installing MySQL on my machine. I'm running a MySQL container, right? So even the MySQL itself, right? It could have its own dependencies and whatnot. I don't care, right? Because why? They're nicely contained in the container. Let's say I'm running Redis, same thing, right? So as you can see now, everything is neatly packaged in little containers, right? So imagine in the shipping in the shipping lines, right? So when a ship is transporting a container, they don't really care what's inside, right? They just pick up the container using a crane and put it on the ship, right? Whatever it could be inside, it could be bicycles or whatever, right? Clothing, shoes, right? Whatever inside the container doesn't really matter, right? Because the container is serving as like a black box. Is that going to make sense, guys? Right? Sort of how the containers work and how we are adapting for our development. So a lot of the time, so when the Docker came out, people said, "Oh, this is great, right? Now we can deploy applications using Docker, right? I'm like this, right? So I'm deploying my application on my server and then running this." But what recently started happening is people started developing application using this methodology too, right? Because now Docker is so lightweight, I can actually run this on my laptop. Then I can do the same setup on my deployment server, right? So the environment is exactly the same, right? So I don't have to set up my laptop at all. We are running in containers, and then when you're ready to deploy, the exact same setup we deploy on, like I say, a Linux server remotely. Pretty cool, right? So now my laptop basically matches what my remote environment says. So there's no more excuse of, how, we always say, "Oh, you need to work on my laptop," because I have a different library. And then when I'm deploying on Ubuntu machine on the other side, maybe it didn't work because why? It has a different version of library, or there's a conflict, what have you. No longer, right? Because why? Everything is nicely packaged up. So is that going to make sense, guys? Right? Just to kind of understand the concept. So the big change is we are using Docker not just for deployment, but also for development. Yeah. So that's a basic, basic idea. So I did a last project. It was like a pretty complex Python project, a lot of dependencies. Basically, the developer and I worked together. We basically Dockerized everything, right? We ran two different databases. We ran a MySQL database and a Redis database, right? Completely Dockerized. And then we ran a bunch of different Python applications with their own dependencies. It so happened like one of the Python app we ran was built on Python version 2. But we were using Python version 3 for the rest of them. So can you imagine, right? If you what did I do it on your own machine? Now you have to manage Python version 2 and 3. You can. It's kind of just a lot of work, right? But now we were Dockerizing it. So imagine like I have a Python app running. This is version 2. Imagine this is another Python app. This is version 3. Perfectly okay, right? Because why? They have their own libraries, own dependencies, not conflicting at all. That is pretty cool. So I'm starting another development now, and I told my developer, do not ask me to install anything on my laptop. Not a database, not caching, right? Nothing, right? Everything has to be Dockerized. So right now, so I'm taking this to like a level like every development I'm doing, it's pretty much everything's Dockerized, right? So we don't have to set up your laptop anymore. All right. So hopefully that kind of gave you a sense of how right I'm planning to use this. So very quickly, one of the cool thing about Docker is Docker actually encourages reusability. Right. So let me show you guys a quick demo here. So when you have a Docker image, right, you can actually share with the world, and this is basically done at the Docker Hub. So we go to Docker Hub, and let's say you want to download MySQL, right? So MySQL people, they actually developed their own version of MySQL image, and then they made it public. So you can see it's a pretty popular image, right? It's been downloaded 1 billion times. And you can simply download the image, right? And then basically run the image. I think I have a command here, right? Let's say you are on MySQL. You simply say docker pull MySQL to download the MySQL image, and then simply say docker run MySQL. That's it. No install, no nothing. Right? So that's MySQL, right? As you can see. And then if you look at each of the sites, again, here's the URL. I'll put this URL in the chat window if you guys are curious. So you can kind of play around, right? You can search for any, right? So let's say you want to download, say, Ubuntu. Sure, right? Even Ubuntu is packaged as a Docker container. Perfect, right? Again, pretty popular. You can see, right? 1 billion plus downloads. Let's say you're looking for Python. Sure. There's no need to install Python anymore. So you can download Python. And also, when you download Python, you see all these different versions. So for example, let's say you want, the latest version is 3.11, okay? But let's say you have a particular library that needs 3.7. Sure, no problem, right? Scroll down a bit, download the 3.7 version. Yeah. So a lot of applications are now, even libraries are now going to Docker way. So they are releasing Docker at a certain, right, with multiple versions. So you can pretty much fetch the version you have. Same thing for Java, right? If you want Java development, right? So you'll see, right? Let's say OpenJDK, right? So this is, this is OpenJDK image, right? And you can see different versions. Now, where was that? If we look at the tags, you will see, all right? So anyway, right? So you can see, right? So again, these are the kind of different versions, right? Version 9, right? This is like a version 19. That's the latest, right? And then if you look at, if you just want version 11, I'm sure if you do a search, you can find it. Say version 11, see, right? So you can pick any version you guys want. Pretty cool, right? So with Docker, let's say you want Java JDK, you don't have to build it. You can simply go download the official image. So this is what we have done, right? I basically put together a Docker stack based on a lot of public images. And also I have some of my own images as well. Okay, so let me show you guys how this is done. And also, if you want to package your own application, right? So remember, this is we are downloading a pre-existing application. What if I want to package my own application? Very easy. What we can do is Docker is very scriptable. We use a thing called Docker file to basically, package the application. So you can sort of read this and you can make sense out of this, right? So for example, you're saying, okay, you're building a custom Docker. You are starting from Python base image version 3.8, right? So let's say I need Python 3.8, absolutely. And then on top of the image, you're installing your own dependencies. So let's say, I need some extra libraries I need. Then you're basically copying your application code. And when the Docker runs, right, when you start the Docker container, it will basically run your application. That's it. So it's like a very simple way of, packaging your application, right? So now, let's say I have, you have two applications. One needs Python 3.8 and the other one needs Python 3.6, right, for argument's sake. Same thing, right? So you're going to build two containers, right? One starting from 3.6, another one starting at 3.8, and then you will install the dependencies, deploy your application and run. So now you can run two containers completely isolated, right? They don't interfere with each other at all. Right? So that's what we are thinking about, right? So packaging your own application is very, very straightforward. Okay. All right, guys. Also, if you have any questions, please post them on the chat window. I'll keep an eye on that. And let me see here. Yeah. And yeah, anytime if you have any questions, post on the chat window. Okay. So now we get the idea, right? You're going to use Docker. You're going to Dockerize everything, even during development. So that brings me to Kafka. So Kafka is basically an open source project. It is very heavily used when you're building streaming platforms. So when I say streaming platforms, for example, think about things like Spotify. You're streaming music, Netflix, right? You're streaming videos, right? And maybe you're building another application that is looking at, say, stock market analysis. So you're getting stock prices coming in real time, and you have to process them. So Kafka is basically a platform to build, real-time streaming applications. Very popular. I've been doing a lot of Kafka training this year. Interesting enough, because Kafka seems to be finally making its inroad into enterprises. So I've been doing a lot of training for like banks, insurance companies, right, media companies, teaching them Kafka because they are adapting Kafka at a very, very fast rate. So yeah, so Kafka's, is here to stay. It's a very, very popular system. And so when we run Kafka, this is a typical setup, right? So let's say I want to run Kafka on my laptop. So what I would do is basically, right, I will say install like a Java, say Java 11, right? Then Kafka has another dependency called Zookeeper, right? So it depends on another package called Zookeeper. So I'll install that. Then I'll install Kafka. Then maybe I'll run like a monitoring UI. And then maybe I'm running my own client application. So you can imagine, right? I'm running multiple components. Now, also Kafka is designed to run on multiple machines. So when companies deploy Kafka, they will deploy Kafka on distributed machines. So for example, they will do like a 5-node Kafka cluster. So Kafka is running on 5 machines, right? Why we are running this in distributed fashion? For scale. So let's say you want more capacity, and let's say you have a 5-node cluster. What we do is we actually set up a, expand the cluster to say 10 nodes. So you get more capacity, right? So Kafka is very good about this scaling. But when you're doing Kafka for training, we will run a single machine, right? We only have one laptop. So we are running Kafka on a single machine. So my goal was, so a lot of the time when you do the training, I get the request, can I run multiple brokers on the single machine? So this is called broker, right? Broker is one instance. Can I run multiple Kafka on a single machine? Just so I can experience the distributed nature of it. And you could do it natively. It's a bit of work, right? You kind of run some configurations, and right, you're be very methodical about doing this. So my quest was, okay, can I do this in Docker? I want to run a Docker stack that allows me to run any number of Kafka machine on a single machine. Remember, this is for development, right? Not for deployment or production, for development. So that was the start of the project. So I thought I would spend like just a couple of hours doing this. And the idea was doing a system like this. Everything is containerized. You can see, right? Kafka is containerized. Zookeeper is containerized. My Kafka UI is also containerized. And I could have multiple applications, one Java app, one Python app, right? And then the only thing I was going to install on my machine is Eclipse for Java development, right? Because my editors and development environment, I want to do on my machine. Everything else is going to be containerized. So I sort of started saying, yeah, let me just spend a couple of hours doing this, and then I think I spent maybe a week or two, tweaking and tweaking and tweaking. Eventually, and this is the project you guys are seeing, right? Let me put this link here for you guys. You can take a look. So here is the link. Again, all of this are in the slides. I'm just giving you guys a link here on the chat window. So take a look. So this is a project and it's open source. And I'm going to walk you guys through this in a second. And this is a basic project, right? So it's called Kafka and Docker. So anyway, yeah. So like I said, what I thought was going to be like a 2-hour project turned out to be a 2-week project. It's because I just kind of couldn't stop. I just kept adding more and more features. All right. So some of the features the stack supports is you can run a very simple stack. One Kafka, one Zookeeper, like one of everything. Or you can run multiple Kafka, like three Kafka brokers. Right? So this kind of gives you this gives an illusion of distributed Kafka cluster. Remember, everything is still running on your machine, right? But when you're writing applications and you're debugging and developing and doing performance benchmarks, it gives you the sense like you're running on a cluster. And the full stack is basically Kafka, like the above, multi-broker Kafka, plus I have some monitoring thrown in. Yeah. So I want to demo these guys to you guys so you can actually download them and use them. Pretty straightforward. So the only dependency is Docker, right? So basically, remember, you need to be able to run Docker on your machine. So I use a Linux and Mac machines for my development, and they are very Docker friendly. Docker runs on Windows too, but it's a bit of a mixed story sometimes, right? Because they're very picky about the Windows runtime environment. But I had people running Docker on the newest version of Windows with the Linux subsystem, right? So that's what I would recommend to you guys if you want to run on Windows, run this in the Linux subsystem, right? Works really well there. Anyway, but basically, Docker runs very well on a sort of a Unix-like environment, right? That's what they need for scripts and whatnot. All right. So we see multiple configuration, and now I'll walk you guys through this. WSL, that's right, yeah, WSL2, thank you, yeah. Now, so for this, I used a lot of Kafka containers that are already built, and I like the one done by Bitnami. Let me show you guys this, right? So let me go back here. So if I go to my Docker Hub and we do a search for Kafka, right? So I used a Kafka image built by Bitnami. So, and you can see, they keep updating, right? They are actively developing this. And this is a pretty nice way. They really package Kafka in a nice way to easily use. So you can just download this image, right, like this, and run it. So I sort of built a lot of kind of a code around this to make it easily usable, right? So I use their Bitnami Kafka, and also they also have a Zookeeper as well. You remember Kafka runs on Zookeeper, so I use both of these. Yeah. So, and also, I had to do a couple of my own images as well. I'll explain. So this is called, I have my own Kafka Manager environment, and also my own Java and Python dev environments, plus a monitoring stack. So for monitoring, I use Prometheus and Grafana. Again, these are very popular monitoring stacks. Again, I use the pre-built Dockers, right? So if you go to Docker Hub and search for Prometheus, right? So again, you'll see it, right? So the Prometheus is basically a very popular open source software to monitor. And then Grafana, same thing, right? Grafana is a UI tool for monitoring. And again, I'll demo all of these in the next section. So anyway, right? So the cool thing is, right? And this is the part I want you guys to understand also, right? See, let's say I want to use Grafana, I can just download the image and use it. And that's the beauty of the whole thing, right? Because I don't have to build this because somebody already did this for me and made it popular. And you can see it's a pretty popular image, right? 1 billion times downloaded. So yeah, right. And this is the beauty of the whole Docker ecosystem. You can mix and match components and build your own stack very quickly. Okay. So now, how do we do all of this together? I use a technology called Docker Compose. Remember, so imagine what happens, right? If you're seeing one of my sample application, I'm running multiple Docker containers. Starting them manually is tedious, right? Because the command lines tend to be like, a little cumbersome. You have to remember all the little flags, right? But so in the Docker commit, recognize this, and one of the methods we use is called Docker Compose. Let me show you guys an example. Again, if you find a Docker, you know this already. What Docker Compose does, it launches multiple containers together, right? So let me show you guys one compose file real quick. So here's a sample Docker Compose, right? You can sort of see it's just a YAML file. So I have multiple services defined. So I say, I have Zookeeper. See, for Zookeeper, I'm using the Bitnami Zookeeper image, right? And then I have a Kafka image, right? And then again, I'm using Bitnami Kafka, right? And I'm telling it depends on Zookeeper. So I'm saying, okay, before you start this Kafka container, you had to go and start Zookeeper first. So it also does dependency management, right? Because some applications will depend on other containers to launch first, right? And also I have another one called Kafka Manager. This is a UI, right? And I say it's also depends on Zookeeper. So when I run this, the Docker Compose will look at this and say, aha, everybody depends on Zookeeper. So I'm going to start Zookeeper first. Once that is started, then we'll go and start the other services. Yeah. So this is a simple Docker Compose file. Again, right? So this starts like one container, and if you look at the full container, right, you can see I had tons of services. Right. So again, no big deal. Docker Compose will do all the work for you guys. All right. So let me show you guys a couple of how to get started. So for this to use this, you need Docker and Docker Compose installed on your machine, right? That's the only dependency we need. So let me run through some demos. Hopefully, right? I just tested them before the webinar, and they seem to work. Hopefully, they will continue to work. So here is a machine. I just spun up. This is just a simple Ubuntu machine, right? And this is what I use for training to my students. And it's basically a simple, Ubuntu box. Only thing it has is like it does some basic like things like editors, Visual Code, and Jupyter things installed. That's it, right? Nothing else. It doesn't have any Kafka or anything. So I just logged into the machine, right? There we go, right? So first thing I have to do, let me make it a little larger, is you need to basically clone this repo, right? Because as you can see, all the files and scripts are here. So clone this repo, and then I'm going to walk you through different setups. So here's my repo. I already have it cloned, right? So I'm going to start doing this. Now, before I do this, let me kind of pause for a minute here and then see if you guys have any questions about sort of the overall Docker and everything else before we get into the demos. Go ahead, guys. If you have any questions, please go ahead and type them in the chat window. I'm happy to answer them. Right? So let's take a quick pause. I want to see if any questions so far. Good question. So one of the question is how much resources do we need, right? This machine, let me show you guys this. Let me start glances. So this is like a system monitoring. The machine I'm going to show you guys, this is like a pretty, what's a CPU? I only have 8 gig memory, right? So it's a pretty simple machine. The machine I use at my home, my workstation has 16 gig, I think, right? Yeah, so not too onerous. You don't need like hundreds of gigs of memory to run this. I would say 8 gig for a minimum, right? And these days most laptops come with it anyway, right? So yeah, so you should be perfectly okay, right? So you can see, right, memory is about 7.7 gig. You can see. So yeah, and this is why I love Docker, because Docker containers are very well behaved, right? They don't need a lot of memory because remember, they're all sharing a lot of resources, right? So yeah, so Docker is not a memory hog. And I know why you're asking, because if you ran like virtual machines, to run a single virtual machine, you need like a 4 or 8 gig memory just for one, right? So, but Docker, and I'll show you guys, when you start running Dockers, you will see here, they will show up. They will run, they will consume like a few hundred meg of memory each. Yeah. So yeah, good question. Thanks, Greg. Any other questions, guys? Please feel free, right? Yeah, because I want to make sure this is this is relevant to you guys as well. Oh, another question I had was what version of Kafka? I am using Kafka version 3. That is the latest. So, right. So if you look at my image, right, I'm using Kafka 3. And if you look at the Kafka, Kafka 3 just came along. So let's say here, right, 3 is the latest version. It's funny, just a couple of months old, very new. Most of the companies, however, are in Kafka version 2, right? Because that's a production version. So most of you will be in version 2 if you're using Kafka, but pretty soon we'll be moving up to Kafka 3. 3 is a pretty big release, right? So in a few months, everyone will migrate to 3. But yeah, you can very easily substitute. Like for example, here I'm using version 2, right? You can easily sort of just simply replace it to version 2, right? So if you go to Bitnami Kafka, you will see it here. Let me see, go back. And you look at the versions or tags. Look at the tags here, right? The tags will tell you the versions, right? See latest 3.0. I don't know if they still do 2. There we go, right? It's 2.8.1. There you go, right? So the latest version is 2.8.1. So you can simply, by simply tweaking the version, let's say I want 2.8.1, I will simply go in here and say, yep, give me version 2.8.1. That's it. See how easy that was? Exactly. Very good. Cool, guys. So here, right. So for this particular demo, I don't have MySQL. So the question was, do we have a MySQL database container? For this particular demo, I'm not using MySQL because Kafka does not depend on MySQL. But let's say you have a use case using MySQL. Let me see. Where was that? Let's say you're building like a web app that in MySQL, then you can simply download the MySQL container. Remember, and right, MySQL is actually published here for you guys, right? So if we go search for MySQL, right? MySQL published already, and the latest version is version 8. Yeah. So even though I'm not using it right now, it's very, very easy to use. Exactly. It's right. You don't have to install it locally. You just simply download the image and use it. Yeah. And I've done this. I'm saying this because I've done this for many, many projects. Works really, really, really well. Yeah. And also, I know they have a MySQL UI. I forgot the name of it. Yeah, that UI is also containerized. So we do. I don't know. Let me see if I can find it. There was a. So I used PHPMyAdmin for my UI, and then I also used another one. I forgot the name. It's like a web-based UI. Adminer. There we go. Adminer is a UI. Adminer. There we go. So Adminer is a very cool UI. It's basically a little web app, but it controls your MySQL. So you like web-based UI, you can like create tables, databases, the whole deal. Very cool. Anyway, definitely check it out. I'll put this link here for you guys. All right. If you want Adminer, yeah. So can you guys see my text messages though? I want to make sure everybody's seeing them. Yeah, because sometimes it only goes to the hosts. Are you guys seeing my text messages? My chat messages? Yeah, perfect. All right. Yeah, check this out. Adminer is pretty cool. And again, right? So simple thing. I just download Adminer and then run it. Bam. So like I said, so yeah, it's a different way of thinking, right? Because rather than saying, oh, I'm going to install MySQL on my machine, I'm going to install MySQL UI, you have to now start thinking about, can I download a container for MySQL? Can I find a container that has a MySQL UI? Right? So you're kind of moving everything into containers. Yep, that's the basic shift in thinking, right? And that's why I'm pretty excited because I started doing this, I would say about last year, and then I was completely sold on this methodology because now I can pretty much like I'm part of a bunch of projects and everything is Dockerized. So all I have to do is like I run the Docker compose file and it'll spin up whatever I need. There's nothing to install on my machine, right? Pretty cool. All right, guys. So let me show this demo. So I don't want to take too much of your time. I want to run through the demo real quick. So if you go to the UI, the GitHub. Here's the link. All right. So project is complete project. So I'm showing you guys 3 configurations. One is like a very simple single node cluster. It only runs one Zookeeper, one Kafka, one UI manager. Why don't we start with that, right? So again, here's a link. So I'm gonna basically follow through the instruction real quick. Okay, so I'm in my larger. I'm in my Kafka, right? Kafka and Docker repo. So there's a we are building some custom images for this one. So I'm going to run some build images, and I'm going to run this once. So this way, it's building my own images. You can sort of see here, right? So it says, building, right? Building Kafka Manager. Should say something like something else, right? Building something else, right? Anyway, right? So these are local images we are building. So run this one time. Okay. So now what I'm going to do, if you look at the project spec, I have multiple Docker Compose files. So one of them is, don't save, is just a single, right? Starting a single Kafka machine, Kafka broker, right? And this is what we are going to start with. And also I have some handy scripts for you guys. So I can say, you can say start Kafka single. And this is a simple shell script. It will basically spin up everything and tell me, right? So let me do that. Again, all of the instructions are right here. So I'm going to start a single version of Kafka. Okay, let's try that. Copy that. Execute this. Okay. Now remember, I don't have Kafka installed on this machine, right? So there's no Kafka install whatsoever, right? So everything's running within Docker. So now you can see how it's starting up, right? Kafka Manager, Kafka, and Zookeeper. So I have 3 Docker containers running, and you can see, right? Machines to spin up. And if you look at my my system monitoring UI, I see this, right? And you can see the how much CPU they're consuming, like memory. Look at the memory, right? Like a few hundred megs. So we add them all up. What is it, like 700, 800 meg? Not even 1 gig. Yeah, pretty cool. And you can even, like, the CPU wise, they are very well behaved because remember, this is a small machine, right? It has only 2 CPUs, I think, and 8 gig memory. So you can see CPUs, right, pretty well behaved. Cool. So now my Kafka cluster is running. So let me show you guys how to access the cluster. So first thing I'm going to do is I'm going to basically log into one of the Kafka nodes. So remember, because I have these machines running, right? These are containers. Since I don't have any Kafka installed on my machine, to do any Kafka related work, I have to log into this machine and do the work inside them, right? Kind of like this, right? So imagine, like, I don't have Kafka running, right? So any Kafka work, I need to log into the Kafka machine and then execute my command. Very simple, right? And the way to log into the command is we use Docker Compose. You can see, right? I'm basically logging in using, I'm saying log into the Kafka 1 component and run bash. So what is Kafka 1? Is my name of the container, right? You can see, right? Kafka 1 is running. So I'm going to log into the container. That's it. All right. So copy the command, execute this, and there you go. So right now, see how the prompt changes, right? Now it says I have no name, right? So right now, because you're logged into some container, look at the number. It's like some random ID, right? So I'm no longer on my Ubuntu machine. I'm actually inside the container. Yeah. So that's cool. All right. So now what I'm going to do, I'm going to create a topic. So remember, I'm inside my Kafka container, so you can run all your Kafka commands. Again, if you're familiar with Kafka, this is one of the commands we use. Like, I want to see how many topics I have created. All right, let's try that. So on this, okay. So right, so right. So I have a test topic I just created before the demo, right? And here's consumer offsets. Okay. Now remember, so this is a command line UI, but we also have a UI as well. It's called Kafka Manager, and if you see this, my Kafka Manager is running on port number 9000. Let me go here, right? So Kafka Manager gives me a very nice visual UI to manage my cluster. So I already have a Kafka registered. So it's very easy to register. You simply say Kafka add cluster, and we simply say, you can give it any name you want, right? Say my Kafka, right? And then my Zookeeper is this. Hey, these are standard port numbers I'm using, right? And enable that, and I think that's it. And hopefully they should connect it. There you go, right? So 2 clusters, right? So Kafka 1, this is something I did earlier. This is something I just added. So I click on this one. So I should see one broker, I'm sorry, right? You only have one machine running. And then you see, right? And all the metrics are kind of showing up. like how many messages are going in, right? How many bytes of messages coming in, all this stuff showing up. Cool. Yeah. And you look at the topics, right? I should have 2 topics. So test topic is the one I use, right? So this is for me. So that's it. So cool. So test topic is created. Again, if you want to create a topic, you can simply go topic, create, and let's create another topic, say test 2. Let's say I want to have 2 partitions and 1 replica factor, right? Again, these are all Kafka specific. So I'm hoping if you know Kafka, you know this, right? So here's my test topic, right? So I have, right, test topic I already had, and then test 2 I just created. And that's why I love the UI. UI is pretty simple and very effective. Because the Kafka command lines can be pretty lengthy, right, and pretty boring. So if you look in Kafka, you know, right? So it's much easier to have a UI to deal with. Anyway, I'm more of a visual person. Cool. So now we have a Kafka machine running. Remember, we're right. If you look at the broker, I only have a single broker, only 1 broker, right? So this is basically exactly how you would done this on your laptop. But the cool thing is running as a Docker. All right, let me do this very quickly. And so we're going to start a console consumer. So this is Kafka console consumer. Let me show this real quick. So I'm running Kafka console consumer here. Let me open another terminal. And I'm going to basically start, I'm going to log into the, do the same thing. I'm going to log into, remember, all the Kafka commands, before you execute them, you need to log into the Kafka machines, or the Kafka container, I should say, right? And that's very easy, just one-liner, just copy that, right? So here right now I'm on my Ubuntu machine, right? You can see my Ubuntu machine. Now when I execute this, you will see it will basically drop me into, oops, did I note this? Oh, okay, sorry, I need to be in the right directory. There we go. Yeah, I always forget that. So now, see, it'll drop me into a Kafka container, right? Cool. So here what I'm going to run is I'm going to run a producer. Okay, so what we're going to do, we're going to basically send a message from the producer to the consumer, right? So my producer is running here. So watch this. Anytime anything I type here, it should come up here. So let's say, right? There you go, right? So it's message number 1 is coming up, right? Cool. So now you can see Kafka is working, right? From a producer, right? Everything is containerized. Pretty cool, right? So this is a single machine system. So this is fine. I mean, it's still good, but it's still a 1 broker system, right? So let's take it up a notch. Let me kind of close all these guys, and I'm going to stop all these. So we can start another one. I'm going to stop this. So again, all the scripts are here for you guys. Just simply have to run them, right? Let's see how it's stopping all the containers. And when you go look at the UI, see these containers will now disappear. See, so then they're being stopped. There you go, gone, right? So now everything is gone. So this is one, great, but we want a little bit more excitement. So what we want to do is, I'm going to show you guys how to run 3 brokers, because this is how the whole thing started, right? A lot of students request me to say, can I run, Suji, how can I run, how can I simulate Kafka cluster on my laptop? Here's how, right? So we did the single node. We're going to do multi-node Kafka cluster. All right. So here's a guide I'm going to follow real quick. So same thing, right? I'm simply going to say start Kafka multi. That's it, right? Take a look at the script. So I'm going to kick off the script and see what happens, right? Run the script. It's going to kick off multiple. It's creating 1 zookeeper. See, it's creating 3 Kafka. Kafka 1, 2, 3. Kafka 1, Kafka 2, Kafka 3. Pretty cool, right? Look at our Docker containers. See all the Docker containers running, right? So 3 Kafka running, 1 zookeeper, 1 Kafka Manager with the UI. Yeah. And don't worry with the CPU early on, because when they start up, they kind of bootstrap a lot of things. So they're so CPU will kind of spike a little bit, and they will settle down. Right? Still look at the memory profile, right? They're just like a couple of 100 memory, right? 300 meg here, and then right. So very, very well behaved. So if you add them all up, not even maybe a gig. Yeah. See how the CPU is kind of settling down, right? Because as you're recovering, you'll see the CPU is kind of settling down, right? Yeah. Okay, good. So now Kafka is running. Very cool. So what can we do with this, right? let me go to the broker and see. So let me go to the Kafka Manager. Remember, this is a UI I'm demonstrating. So I called it Kafka 3. See, I have 3 brokers. Ta-da, this is what we wanted. All right, so if we click on these, you should see Kafka 1, 2, 3. 3 brokers running. So now we have a sense of we are running in a Kafka cluster, but everything is running on a single machine. Pretty neat, right? And also it'll kind of give like a metrics, like things like, how busy the clusters are, how many messages coming in and all that, right? So that's it. Let's look at the topics. So I think I already have a test topic created before the demo, so you should see it. Yeah, there we go, right? I have a test topic created, and we are going to send some messages through here. Okay. So for this one, since I have a test topic created, let me log into a Kafka node. Same process, right? Remember, you're logging into a Kafka node to run any Kafka commands. So let me log into one of these. Okay. And I'm going to run a console consumer just so we can see what's going on. Again, remember, I'm running these commands within the Kafka container, right? Not on my machine, because my machine doesn't have Kafka. All right, so you can see, right? I'm running this in the Kafka container. Good. So I'm going to let this guy run. Now we are going to run a Java and Python application. So now even for this, I have them Dockerized. So let me show you guys how, right? So for the Java app, I have a Java dev environment. So if you look at the start Java dev environment, basically even this is basically using a Docker environment. So you can the script is setting up, right? So I'm using the Maven image for as my Java environment. So I don't even have Maven installed locally. Everything is in the container, right? So it's going to spin up a Java container. See what happens when I run this, right? So I say start Java dev. Let's go here. It's going to spin up a container, right? It's going to drop me into Java container. So I have a sample Java application. So I call sample of Java, right? Let me go there. And if you look at this, I actually have as part of the Docker, part of the repo, I have some sample Java app. Very simple, right? I have one consumer and one producer. That's it, right? Sample Java application. So what I'm going to run our Java consumer. Okay, so what do we need to do first? Remember, because right, we are running a Java application. So first thing I need to do, I need to build the Java package. I'm running Maven. Right, very good. So I'm running Maven within the container. So it should go pretty quickly because I just built this before, right? Before this one. All right, so I'm compiling my Java code. All right, great. And then I'm going to simply run my consumer using my Java consumer. All right. There you go. That's done. Let me run this Java container. So I have 2 consumers now listening, right? This is a console consumer and this is a Java consumer. Now let's mix it up a little. I'm going to run a producer, not using Java, but using Python. Right? So I even have a Python dev environment set up. So again, right? So Python dev, we actually have a, if you look at the start Python environment, you will see it's launching another Docker that we built, right? So I have a, right, here's a Docker file for the Python. So I'm using a Python 3.8. And you can see I'm installing all the Kafka libraries and everything. So it's, yet another container, right? So basically what I have, so let's actually bring this up here and start this up. And that should drop me into the Python environment. All right. So let me go to the Python app, sample app, Python. Remember, so I write all these containers running. So let me run the producer from Python. Okay. So my producer is just sending like a little hello world message, right? It's going to send a bunch of messages, and you can see, right? Messages already started coming out in the Java, right? Java console. See, it's kind of saying, hey, I'm getting messages. Also, we go by the console, it's getting messages too. So now, right, we achieved this, right? I have a Kafka running. So I have actually 3 Kafka, right? So instead of 1, I have 3 Kafka containers running, right? And actually, yeah, right? And I have Python client, Java client, Zookeeper, Kafka monitoring, everything's going on. Pretty cool, right? So, and you can see everything is Dockerized. And if you go look at the UI, you will see, right? If you look at the brokers, see, so the traffic started picking up. See the messages are coming in. Cool. So even the container, so even the dev environments are containerized. So I don't even have to install Python or Java on my machine, right? So if my Kafka program is using, say, it needs Python 3.8, sure. And let's say I only have 3.6 on my laptop, no biggie, right? Because, right, I'm running this in a container. And as you can see, let me show you the right container so you can see, right? Like I have, right, all these containers running. So you can see, right? My Kafka containers are running, Kafka 1, 2, 3 is running. These names, Trusting Woo, Crazy Bears, these right? I have two new ones. One is a Java container, other one is a Python container. Remember, I have two extra, right? One for Python, one for Java. And they're all running. You can see, right? The Python container is just taking like 147 meg, right? So there you go. So somebody asked me, right, this when I'm starting, how much memory do you need? Not at all, right? So I have an 8 gig memory machine. I'm only using 3 gig, right? And that's like everything, right? Docker plus everything else running. And you can see my CPU is pretty well behaved, right? And you can see, right, I'm sending messages, right? So I think I'm sending like one or two a second or something. And if you look at the UI, you will see, right? You can look at the topic. You can see, right, how much traffic is going to the topic. They'll tell you, right? Yeah. So basically, 2 messages per second is what I'm sending, right? Pretty cool, huh? So full-fledged Kafka cluster running in a single machine. And this is what I really wanted to kind of achieve. Like I want to run multiple Kafka brokers on a single machine. Now, let me show you guys one more, and because that's what took me a little longer, right? So I basically achieved what I wanted to achieve at this point, but I want a little bit more. I want to have some more monitoring. So let me stop this here, right? Let me go through and kill all these guys, exit out, and the last demo I'll be very quick. Okay, so I'm exiting all the containers. So really I'm going to stop, right, all the containers, right? So when you see, right, you see all the containers kind of winding down. Watch here, right? See, they're kind of disappearing. Very good. So the next level up is basically running a full stack. It's going to run everything we just ran, plus it's going to run a pretty extensive monitoring stack using Prometheus and Grafana, right? So it's going to run crazy amount of containers. And before I go, right, this is what's happening. So what we are doing right now is kind of just to show you guys what's happening on my machine. What just happened was, I had like multiple Kafka brokers running, right? And a Zookeeper running, and a Kafka Manager, and also Java Python dev. So you can see all of them are containerized. And the reason they all worked very seamlessly is because they are all part of a Docker network that is specially created for this, this stack. So they all kind of, bind the Docker network. So everything's kind of self-contained, right? So yeah, so you can see, right? I had running 7 or 8 containers, and my memory didn't even blink, right? Maybe like I had like 1 gig of memory between all of these guys. And they were running, and they're sending messages, back and forth, right? So it's not like an idle cluster. So basically, on my laptop, I just have an Eclipse because to do Java development, and maybe Visual Studio, right? Whatever you guys do, that's it. There's no need to install any of these guys. Is that going to make sense, guys, from a setup perspective, right? Yeah. So that's the whole goal of this one. I'm going to show you guys one more thing real quick, and then right, because this is pretty cool. Let me start the next one, which is basically a full stack Java. I'll do this very quickly. Okay. This is going to start a crazy amount of Docker containers, you will see. Okay. So let's watch here. I can see, right? Because in addition to our Kafka Zookeeper combo, it's going to also start Prometheus and Grafana. Because why? Because they actually give us pretty good insight into what's happening in our Kafka, right? So you can see all these containers running, right? So now my CPU is spying a little bit because, right, I have all the monitoring things are kind of running. And this monitoring software sometimes can be a little taxing, right? And also remember, this is a very small machine, right? Just 8 gig memory with 2 CPUs, right? So it doesn't have a lot of horsepower, but it'll run just fine, okay? All right, so what's all this running? So I have, right, Kafka, my usual Kafka running, I use Zookeeper, but I see like it's some new ones, right? Grafana, Prometheus, all of these guys. So let's see how these guys are working. All right, I'm gonna do the same thing, right? I'm gonna basically do the, right? I'm gonna do a quick, I'm gonna run through a quick application. So if you look at my Kafka Manager, you will see, okay, so this will take some time to kind of load up. So I'm gonna wait for that. But let me start a Java environment. So I'm gonna do Java and Python, right? So I'm gonna run a Java consumer and a Python producer. All right, cat. And then, yeah, Maven clean package, and I'm gonna run the Java consumer here. All right, and I'm gonna run the Python. No, actually, sorry, it should be in Java application. Sample Java application, then run the consumer. All right. Same thing, I'm gonna run the Python environment, right? Again, remember, everything's Dockerized, right? So we are starting a Python environment. And let me start here. Sample app Python, and I'm running the Python producer. That's it. So you can see, you should see messages, right? Python is sending messages, Java is getting. So even the languages are mixing up, right? One Java, one Python. Great. So this is working. And let me see if this UI is back up. There you go, it's coming up. So here's my Kafka, right? Again, same as before. So I see 3 brokers, all good. And you see, right, messages started coming in already. Pretty good, right? So you can see, right? So I have 3 brokers. Traffic is flowing back and forth. Now here's a kicker. We actually have Grafana. So let me bring this up here to you guys. So Grafana is listening on port number 3000, I believe. Yeah. And let's see what's the Grafana username, password. Username, admin, password, Kafka. All right. So admin Kafka. So this is an addition to the Kafka stack, right? So what Grafana is going to tell me, right? We have this dash again. If you're familiar in a Grafana, I'm a big fan of this. So let's see what's happening with my memory. So I want to understand my Kafka, how much memory they are using, right? There you go. So right, let me zoom in a little bit. It says last 1 hour. Let me zoom in like last 5 minutes. See, here's how my memory usage is with my Kafka clusters. So you see 3 clusters, right? Kafka 1, 2, 3. And here's the memory usage. Pretty cool, huh? Right? So remember, the clusters are running, right? Because you can see the messages are going back and forth, right? So clusters are running. So now I kind of get an insight into how much memory these guys are using, right? Right away in Grafana. And remember, all of this is being powered by Docker, right? Let me show you guys one more thing. For example, let's say go here. Let's say I want to look at, say, topics, right? So here, right, again, let me zoom in a little bit to 5 minutes. So you can see here, right, my messages are basically, right, let's say I want to look at the test topic, right? So you can see, right, basically, we are kind of basically message in per second, how many? About 2 per second, right? That's right, because I'm writing 2 messages per second. You can see, right, how many messages are coming in, how much data is coming in, how much data is going out. All of this using Grafana. So again, if you use Grafana, I mean, I'm just showing like the very basic version. Grafana can do a lot more, right? You can zoom in, right? I mean, there are a lot of things you can do. So basically what we have is we have a full Kafka cluster, right? With actual, right? All the Grafana goodies, right? So now I have set up Prometheus and Grafana to basically extract metrics from Kafka, and they're going to show you what's happening. That's it. So now you can see that, right? So the messages are flowing through, and you should see it in Grafana, right? So let's go back to, let's look at how the OS is doing, right? So now you start seeing the memory is kind of, not bad, huh? So, and all of this, just one command, right? Basically, all we have to do is simply say start Kafka, and where was that? that's it, guys, right? So that's basically the crux of the demo. Sorry, we are a little over time, so thanks for sticking around. Let me show you, let me wrap this up real quick. So you guys have seen what is possible. You can run multi-node clusters with the full monitoring stack using just like a one command. So the repo is fully self-contained, and you can start running it. Again, all we need from you guys is being able to run Docker. You don't even need to have Java or Python installed, or not even Kafka. Everything is containerized. So again, remember the architecture, right? All the containers are running, and they're all part of binded to by a Docker network. So they can talk to each other. Like for example, right, the Kafka brokers can talk to each other, right? Your Java application can talk to Kafka brokers, because all of them are part of the same network bubble, right? So the code is open source. I'm hoping you guys are able to try it out, and then please let me know any feedback. I'm very curious to kind of see how people are going to be using this. I had to do a lot of work to kind of make this easy to use, because even though these components are kind of out there, like there's Kafka container, there's Zookeeper container, but putting them all together took a lot of effort. And I hope this is useful to some of you guys. All right, so that's that. Demo done. So next up, when I get some time, I'm going to do the same thing for Spark and also Cassandra. And my ultimate goal is have like a Spark, Cassandra, Kafka combined stack running in Docker, right? So this will take some time. So that'll make a full network streaming platform, completely Dockerized. So everything will be running as a single, on its own Docker, and you can run streaming applications. Yeah. So I will keep an eye on your email. When we have this, I will email it to you guys, and then we'll probably do another webinar on this one. All right, guys, that's it. Thank you so much. Again, check out the code. The link is here. Let me put the link to the presentation one more time real quick, just so you have it. And then any questions? Please go ahead, please. So let me. So here's a slide deck, and we will email you the slide deck and the and the webinar recording and everything. So no worries. All right, guys. Any questions on this one? Please go ahead. We are done. If you need to drop off, please do so. But if you have any questions, hang back. I'm happy to answer any questions. Oh yeah, so the code is actually in GitHub, right? So here's a link, right? Yeah, it's open source. You can download it. I'll put this link here. Yeah, you should be able to use it. And remember, all these links are in the slides, right? So when you download the slide, you will get all the links. So don't worry. Yeah. All right, guys, that's it. So thank you, and enjoy your holidays. And I guess we will see you guys next year. Thanks. Okay. Thank you all. I appreciate your time. Yes, we will send out an email with the recording. Don't worry. Yeah, it'll take a day or two, but we'll send out a recording with the demo, with the recording. Yeah. Don't worry, you will get them. Good, guys. Anyone has any questions? If not, we are done. Enjoy your Friday, and we will see you in some other webinar. Yeah. Thanks all.